Hi there, CycleCamp here. Hey, let's put together a QRP Labs station clock kit. Basic assembly and a little bit about how to program it. So basically this is what you get with the kit. There's really not a lot to it. Most of the work is done by the microprocessor and the code on the microprocessor. You've got a couple variable pots, a couple switches, some mounting hardware, some what do you call it, connectors for these things to go into. Very nicely done circuit board, couple caps, transistor, crystal, resistor or an inductor, it looks like a resistor, and some wire, I don't know what that's for, and then the display. So it really doesn't look like it's going to be too bad a kit to put together. The circuit board is nicely solder masked, it's done pretty well. It is a little bit of a tight kit. I can see it's going to be some tight fits. There's a lot of 0.1 spacing on here, but no SMD parts. It's all through hole, so it should be pretty easy to put together. Now I'm not going to bore you with me actually soldering this thing up, because that's really a pain in the butt. If I do see some interesting stuff, or there's something I think you need to be aware of, I will make a quick video of that and insert it. But other than that, I'm just going to solder it all together and then try whacking it up. So let me get my soldering iron heated up and my third hand going, and we'll see what happens. So before we get started, I'll just show you what I like to do. I have this piece of styrofoam that I like to use, and I like to organize all my parts, because I do go through the parts list to make sure I've got everything I'm supposed to have. And I put everything in order and I label it so I know what I'm looking at. Now, this is a funny kit because this is everything you need, which doesn't exactly look like what I showed you before. And the reason for that is, if you look inside here, you'll see you've got these grayed out ones. So there's 200 nanofarad capacitors that are used, but they give you a stick with 6 on it. I've taken 3 off and put them in the styrofoam. Also, things like the BS170. Well, turns out they included a BS170. Don't know why. Same thing with other parts. So this here is the pile of parts that you're actually not going to use. 2 10-pin headers, 2 4-pin headers, wire to wrap a toroid. I think that's an inductor after I looked at the banding on it. The BS170 and a couple of caps. So this is going to be an even easier assembly than I thought. Now the way I do this stuff is I use a third hand. This is the one that I use. It works pretty well for me, and I'll clamp the board in it, and then so I can flip it. It's got this thing here, you can flip it up back and forth, and that's what I do that with. I just use a cheap soldering iron. I don't use anything really special. I do use a decent cleaner. I gave up using sponge pads, so they don't work very well. And that's basically how I put this kind of stuff together. When I actually solder a component, what I end up doing is, when the component lead comes through the hole, I actually rest the solder on the opposite side of the plated through hole, pushing up against the part. Then I bring very thin solder. I use very thin solder for this stuff, just to give you a feel for how big the solder is I use. That's really tiny stuff. You can see that'll almost fit through the plated through hole. That's how small it is. And I put that in from the other side, so the part has to be hot to melt the solder, and that way I get consistently really decent joints. So while it looks like I might be going real fast or that kind of thing, it really works well. So I just wanted to give you a thing about the setup. Always go through the parts list. Always lay your parts out and count them. Make sure you've got everything you're supposed to have. I did forget to mention, when I have mechanical parts, I put them in a little jar with a lid on it, because I have a tendency to do stupid things and push stuff around and knock things over and off of my work area. It's a very tight work area, because this is where I do my computer work and where I pay my bills and all that kind of stuff. So it's a very small, if you went up high on the desk, you'd see there's really not a lot of work there. I mean, there's my station with all my radios and my computer and all that stuff. So you can see there's not a lot of work in the room here. So it's really important to stay organized and to have stuff stuck so that it doesn't drift around. Anyway, I thought you might enjoy that little tour. Now I'm going to go to work and get soldering this thing together. See you in a bit. Hi there, I'm back again, and we've started putting the board together, but I did want to point something out. So I'm putting this together in the order that the assembly manual says, and it says to install switches S1, which is here, and S2, which is way over here. And one thing I want to point out to you is, at first blush, that switch looks square. And while the body of the switch is square, if you look closely at the pins, this is a rectangle. It's shorter in this direction than it is in this direction. So do not force the switch, is all I'm trying to say. If it doesn't drop in there really nice, double check and make sure you have it oriented properly. And that's a good rule of thumb for any mechanical components you put in. Mechanical components you put in. You may find that even though the switch itself is square, the leads are not. So be careful when you put components like that on a circuit board to make sure you're orienting them properly. Okay, we've got it pretty much done. I want to talk about two quick things. The first thing is jumper options. And I'm just looking this up on the board here. So I went with the jumper that says allow me to have software variable brightness. So I put that jumper in. And that jumper is, if you look at the picture, it's this option here where A0 goes to A3, and there's no resistor installed. And you can see that, where can you see that? You can see that here. Let me see if I can get a little bit brighter picture here. So there's A0, there's the pads, A0, 1, 2, 3. A0 is jump to A3 and there's no resistor installed. The second software option that I took was optional for a 220 ohm resistor. I'm sorry, here we go. 220K for R4, which makes it less sensitive to the contrast adjustment. I didn't care about that, so I went ahead and put the jumper wire in the position shown, and that's over here. You see there's a resistor at the top of the board, and there's a jumper there. The jumper is the one we're talking about. Okay. Then the last thing is a 100 ohm resistor for microcontroller reset, which allows you to do in-circuit programming. And since I have a friend that had one of these, actually not a friend, but I have an acquaintance, Dave Kassler, who put one of these together, and it turned out the software was screwed up, and he needed to reprogram the software to straighten it out. I am going to put the 100K resistor, and that's in that same spot. That 100K resistor is that one right under here. So I did install that 100K resistor. The next thing I want to talk about is the connections for the LCD module and the main board. So you've got the LCD module, and it has a connector on it, which is the receiver, the female version of a 16-pin jumper. And that was a pain to solder because these are copper tabs. They are not plated through holes, so the solder does not flow well. So just a warning, that's going to be a little bit of trouble. And when you put the matching connector on the board, I didn't do it this way, but what they suggest is that you just barely, you leave some space here between these little black plastic pieces and the board, because when you put these together, they're too tight. I'll show you this here a second. Hold on. Okay. So if you put them together like this, and they're put in together tight, you don't have enough room for the plastic stanchions that go between them. They're just a little bit off, you know, like a board width off. But I don't really care. I don't mind having that little bit of space. Hold on a minute. Like this, between the two connectors. That didn't bother me at all, because they're really long and they connect really well, so I don't really care. So you know, if you're going to do it, Do it the way they tell you to do it. Don't do it the way I did it. But I just want to let you know. And other than that, we're just about done. You can see this board is a multi-purpose board. It does a couple of different things. It has options for GPSs and stuff. I added these. That's for the GPS. This is in case you want to move some of the stuff off the board, like the switches, or if you want to put it in a box and you want to put the switches out there. This is a programming header. This does not come with the kit. That's why I used a blue one, so you can tell it didn't come with the kit. Things like that. And there was also one other, that 100 ohm resistor, 100k ohm resistor that I put in there for the microcontroller reset. That does not come with the kit. I added that myself. So that's basically what's going on with this. And now I got to find a 5-volt power supply and light this thing up. Okay, so it's time to try to crank it up. So here's another kit that I made from a parts kit that I got at a Hamfest one time. It's a pretty well regulated supply. It is a little twitchy as far as the setting is concerned here on this switch, but you'll notice the flashing and all that junk. That's because it has the ability to also act as a logic level driver and a logic level detector. So in addition to a supply, which comes from here, you can also hook it up and, you know, put a very slow pulse out or check to see if there's stuff pulsing in anyway. So here's our little guy here. He's all put together and all the screws are in and all that stuff. I elected to use the GPS connector for the power because the GPS connector is the only place where power and ground are right next to each other. In the main connector, they're separated by another pin, which didn't make any sense to me at all. So I'm going to take the clip and clip up number 1 here, the negative side. Now I'm going to clip up the positive side. This is where we see if the blue smoke gets released. This will be lots of fun as I get my finger on this thing. These connectors have really lousy, slippery covers on them. These alligator clips. Okay, so we have hooked it up. The backlight is on. I can see the backlight is on, but I don't see any lettering, and that's okay because they say that's the way that's supposed to be. When you first put this together, the contrast control, let me turn this light off, you can see the backlight is actually on. You see this light lit up there, but the contrast control needs to be adjusted until you see it come in. So let's take a screwdriver and we'll hook up to the backlight control and we'll see if we can get it to do any whoop, whoop. There it is. And they said it would be twitchy, so it's hard to see, but it says diagnostics mode, which is exactly what it's supposed to say. So that's pretty cool. So I mean, it's not very bright, so we probably will have to adjust some of the brightness here. And unfortunately, that involves changing resistors out, which is a real pain. You can do it with this. Let me raise this up a little bit so I have room to work. Okay. So now we're raised up. Okay. So if I go under here and grab the diagnostics again, grab the thing again. You see now it just faded out because the contrast is too light. And then we come forward and up it comes. Also, I haven't taken the plastic off yet. I don't think it's going to make a huge difference, but we'll pull the plastic off. And no, didn't make a huge difference. So there's diagnostics mode, which is what it's supposed to say according to the manual. And then let's see what we're supposed to do next. So I'm just flipping around in the... Okay, so we did the module assembly, and we have all the little letters, and we have the words diagnostic mode, and oh, actually it's probably kind of low because we haven't told the computer to up the brightness either, so that's probably some of that. So we've made our power connection, we've got diagnostic mode in. I don't care about in-circuit programming, I don't care about power, resources. Must have walked right by it again. There was a set of pictures in the manual that I'm flipping off here to the side that said here's the sequence of events that you should see. So okay, so here we go. when you see diagnostic mode, all is well with the processor and LCD communication. That's good. When you press the left button, diagnostic mode will be cleared. Now, that's a good question. Is the left looking at it from the back, or is the left looking at it like this? And I don't know. So that's a good question. So I guess I'll push the one on the left. It says it's setting up, so that's good. Let's see what it does. And it gives us the clock thingy. And it's running a clock, it's running the count, but we haven't set it yet. But it looks like it's powered up. I see all the things I think I should see as far as, you know, time and all that stuff. Now, I do not have the GPS module attached to this. I do have one, but I do not have it attached to this. So we'll see what happens. But I think now what I have to do is, now that it's all doing what it's supposed to do, I probably have to go get the operator's manual for this and open that up and see what's going on. So let's get that open and see if we can figure out what happens there. Okay, so we have we found a little problem. We had a bad connection. You can see, oh, it's nice and bright now. Life is good. And it turns out that this device has an electronically alterable PROM in it, an EEPROM. And when you get the settings all set up, it won't go into diagnostic mode. It'll come into run mode automatically. But first you have to set it up first. Now, this is a fairly difficult thing to set up because there is a bunch of things you have to go through, and there's only 2 buttons. And some of the things are alphanumeric and some of the things are Boolean. But we're going to just try to set it up for a very basic, just show me the time, and I want to see the UTC time. I don't want to see the UTC. I don't want to see my local time, because that's the whole point of having this. So I'm going to push the left button, and now it's going to go into its little setup. And now I'm going to push the left button again, and now it's going to start going through the decisions it wants to make. So this is how line 1 is going to be displayed. So DD, let me see, let me get this out of here. So DD is the day of the UT date, and DM is the month of the UT date, and DY is obviously probably the last 2 digits of the year, right? Yep, the year of the date. And then HB is, what is HB? HB, I'm looking at this big table they have in here, which of course, you know, you would think they would put it in alphabetical order, but no, that would be too easy. So HH, GD, and HB is the 1 pulse per second heartbeat. So every time, if you had a GPS attached, or you had a 1 pulse per second heartbeat coming into this thing to discipline it, that would be your guy there. And then H8 is the UT, Universal Time Hours in 24-hour format. So that's kind of cool. And then you've got the colon. So that's on line 1. And we'll leave that alone. Well, let's see what we want to do here. So I don't want to see the HB. And I think what you do, yeah, okay, so you press the right button and you can come over here, whoops, and change this around. So I'm going to change that back to a pound sign like it's supposed to be. 7, 8, 9, A, B, C, oh good Lord, I'm going to have to go through the whole alphabet here. N, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, blank, slash, plus. Oh yeah, you can see this is going to be really boring. I may skip through this, so if the thing all of a sudden starts taking off, you'll know why. Alright, so I'm going to come over here to where it says pound HB, and I want to delete it. So now I need to understand how to delete it. So, delete, if the current pressing the left button has no effect at deleting, so backspace is delete. Okay, so if I set it to the arrow, the back arrow, that one there. If I press the left button, then that gets deleted. Oh, perfect. So let's do that again. So now we got to go around and find it again. So this, obviously, you're going to spend more time setting this clock up than you are doing anything else. So now we're going to get rid of that character, and now we're going to get E. Let me loop around again. It's kind of nice that it starts off wherever the character was and picks up from there. That's kind of cool. I do like that. I used to do telephony. Don't hate me. I used to do voice response systems. You know, like the stuff you get when you call up and say press 1 for English and all that. So I'm used to these kinds of problems. So pound HH is give me the hour, and then pound MM. Then the semicolon is like a fixed thing, and then the pound MM is going to give you the minutes. So let's see what we got here. So pound MM, Does it anything special about the minutes? Those are UT minutes. So HH. Excuse me. Oh, I shut this radio off. Okay. So pound HH are the universal time hours, and pound MM are the universal time minutes. So I'm gonna leave that just like that for line 1. I like that for line 1. And then, so let's skip ahead here. And we're still on line 1 for some reason. I don't know. We're gonna get over that. So we got SS and AA. I don't know what SS and AA do. So SS is UT minutes. No, SS is UT seconds. I'm sorry. And then NAA is, who knows? I don't know what the AAA. Well, all those I guess those are just like supposed to be spacers or something. But we're good there. So we're gonna. So the question is, how do I get off of line 1? How do I continue? Is that like a long press? So editing, retypes, number editing, alphanumeric editing, blah blah blah. Enter finish. Oh, so you have to select the enter character. Okay. So we're going to go through here, and the enter character is like the one on your keyboard, the little down and sideways arrow. Okay, so let's skip forward, delete. I don't know what that is. And that there should be enter. So if we hit that, then we're done with line 1. So now we're on line 2. So line 2, I think this is all GPS stuff. So line 2 GV is GPS validity flag, and GG is the fixed status, and the I don't know what the F is for, or the little f is just a letter, right? So you're going to have whatever GV is in this 3, then a space, and whatever GG is in these 3, then a space, and F, and then the next 3 is going to be GF, and GF is, if you had the number of satellites, use compute the solution, and then you're going to have a T, and I would bet you $1 that that's GT, but I don't really care. I'm just going to leave that alone. And we don't care about line 3, and we don't care about line 4. And how long does it stay on line 1? How long does it stay on line 2, line 3, and line 4? I don't care about upper and lower case. I don't want to do temperature calibration. You can add temperature sensors to this, which is pretty slick. GPS mode, I don't care. GPS checksum. Local offset. Now that's a good question. What the hell is a local offset? I wonder if that's the offset of local time to UTC. The time is displayed. Yeah, who cares? I'm not displaying any of that anyway. So the local offset. So my local offset right now is 4 hours, and I am 4 hours behind. So just for fun. So 4 times 60 is 240, right? So we'll go 240. 240 minutes. Okay. Time zones ahead or behind. And this is offset by the number of minutes. Okay. So that's cool. So we will enter that. And this is all relay stuff, and I don't care about relay stuff because I don't have any relays on here. I don't care about alarms. I don't care about local alarms. I don't care about any of this stuff. This is how fast the system clock is running. It's 20 meg crystal, and the backlight is set to 9, which I believe is the brightest it can be. So that's pretty cool. So we'll leave that alone. So now we're going to set the time. So what time is it? And now we got to double check something here and find out if we're setting it to UTC time or to what do you call it, time. So let me skip forward in the manual. System frequency, backlight, set time. If you have not collected, so I haven't connected one. Clock seats are fixed, they're not displayed, set to 0. This configuration allows to set the real-time clock. The clock setting takes effect and the seconds are counted but not displayed or set to 0 when the left button is pressed after setting the minutes. So I'm going to go ahead and set this, and I'm going to set it to UTC time, which right now is 2050. 55, 0. It's probably wrong, but now this right button to start, you have to press the right button if you want this configuration to be saved to memory. Otherwise, it forgets it and starts over next time you power it up. So I'm going to push it. And I get 20, 50, 19, but I got a whole bunch of stuff in the beginning that I don't really want. And I don't know why. But it is, the clock is set. So that's kind of cool. And these, obviously, this is the line 2, the GPS line, which is not displaying because there's no GPS installed. So he's saying, hey, I don't have any valid data for that. So that's pretty cool. So I wonder how we get rid of that other stuff. No, I don't see a DDDM-DY. Oh, I didn't tell him what the date was. I never did tell him what the date was. So I wonder if there's a date thing in there. On off. These are for controlling devices, relays and stuff. Alarms, alarm local, relay init, system frequency, backlight, set time. So I can set the time. Well, I can set the time, but I can't set the date. That's pretty interesting. Well, I'm going to have to go look around that some more. But apparently you can't set the date. Apparently you have to have a GPS connected if you want to actually show the date, which is kind of weird. And the date would be here, right? Month, day, year, whatever. But I don't see it in here. But anyway, so that's basically the kit. I'm going to obviously have to mess around and see what else is going on here. So I did some more digging, and it turns out that the GPS-based stuff, like the UT time and date and all that, only are valid if you have a GPS connected. And that's why we were getting all those dashes in the front of the display before. So I dug out my GPS, and this actually is the GPS kit that is recommended for this particular guy. And it's not a very hard kit to build, as you can see. It's pretty straightforward, and this is soldered in for you ahead of time. You don't have to do that yourself. All the rest of this stuff, actually there's a couple other, no, everything else is either through hole or not a big deal. So anyway, this is a GPS that has a really big antenna, so you can use it indoors. The grounding plane of the antenna is really big. And what you can see here is this is supposed to be red, yellow, and green, but my yellow LED was messed up, so I put 2 reds in. So this is power. This one here in the middle is the 1 second heartbeat, and the green one is the data. And I plugged it in, and I set up my GPS, and it didn't do anything. Nothing worked, and I couldn't figure out why. and I wasn't even getting this little heartbeat. That little heartbeat is that pulse, so that goes in time with this guy. You can see whenever the green light flashes, this guy comes on. Well, what happens is, it turns out there's a setting in the clock that says whether or not you are using a GPS, and that was I'll get it for you here. That was here. And before, remember, it said mode and baud, it was mode 0. Well, mode 0 says do not use the GPS for anything, just ignore it totally. So, and that's the bit rate of the GPS, which is 9,600 bits per second. So, because I had that set to 0, nothing was working. But now that I have it all, hooked up, and the GPS is actually doing stuff, it's actually doing its thing. So I'm pretty impressed. I don't have to worry about setting the time, so we'll start it up again. So we're getting 12 June 20. That's the GPS date time stuff, and date stuff. Day, date, month, and day. And then, because I don't have any interspacing characters here, right up against it is 21, 25, 30, which is the GPS, the UTC time, which is correct according to my other clock, which I have UTC time set on. But the reason I can't use this clock is because in order to see it, I have to push the button, and it's really not very bright at all, and it drifts. It drifts too much. It drifts 30, 40 seconds a week, so it's not good at all. So that's why I was building this in the first place. So what I'm going to do is I'm going to go back to this line, and I'm just going to put a space in between these two guys, and that should do it. So just for fun, if we were to do that, so we have DD, DM, DY, and then we want to insert a space. So first I'm going to have to go back in the book and find out how to do an insert character. Okay, so the insert is the other arrow. So if we go right here and we say walk around, that's the insert. So we're going to say insert a space. Except what it inserted was an A, and now we have to go around to find a space. So we're going to QRSTUVWXYZ, and I think that's a space. So we will continue over here, and then we had all of these A's that we put in here by mistake, and we would need to get rid of all of those. So that's and that's a question of going through here until you hit the delete mark. And where's the delete mark? Delete mark is the arrow that's in the other direction. That's that guy. So he deletes and then he comes back. So I'll just go through this. I know it's boring. Once you get this all set up, it's kind of slick, but it does take a little bit. And I am probably going to get a box. I think they sell a box for this if you want one. I just had never, didn't think I was going to want one. I'll have to find out about the power supply though, because this takes a 5 volt. Now, one thing I don't like about this is it takes a 5 volt supply instead of a 12 volt supply. And if it was me, all your other gear in the shack runs on 12 volts. So why not have a 12 volt supply? It just makes sense to me. So that is one. If I had to fault the kit, that would be the one big fault of the kit I would have, is that I really don't like the fact that you have to use a 5 volt regulated supply. How hard would it have been to put a 7805 little mini 3-legged transistor style regulator on there and a couple of caps? It wouldn't have been a big deal. Now we're getting in trouble here because we're doing this again. So now we're gonna bring this around until we get the get me out of here character, which is the enter sign. And we're gonna say there it is. So that should do it. So that's the end of line 1. Oops. I'm gonna have to do it again because I pushed the wrong button because I'm an idiot. Second. Okay, so here we go. So now we're at the end of the line, and we're going to go find the get me out of here character again. Found nothing. Insert, delete. I don't know what that does. Backspace maybe, and get me out. So there I am and get me out. So now we're just going to run like a rabbit through the rest of these, and hopefully that'll fix our display up. So you can see that setting this, it's fairly easy, but man, it does take. There we go. Now it's beautiful, and it does take a while. So now you've got your 12 June 20, 21:30, hours, and there's our pulse coming in from our happy little GPS unit. So sorry I took the extra time here. No problem. But hope you enjoyed this, and it was a pretty simple kit to put together. Looks like it's going to work pretty cool, and I look forward to getting it all into a box where I can actually use the darn thing. See you later. Have yourself a fine day.